Here we are back at our goldfish. So we've adjusted it in two ways. Neither kept it proportional. Now we'll try it again. So I now adjusted the length and the width of the original image by making both of them half of what they were before. So that sounds kind of promising, right? Here's again my fish. Here I'll show you my, I'm going to just bring that guy up here, my little fish. He's a pretty cute fish, right? And there he is. So this is half, so notice you can even tell the height, right, is half, if I can fit two of them, and the width, I can fit two of them across. So it should be perfectly half on each side. So just by looking, does it look like I kept it proportional? My thought is yes. And you might have, I'm sure you've played with images before, right, where we can sometimes distort it if we pull on one side, but even on the last one we shortened both sides and it didn't work. But when you pull on the corner, remember how it keeps it proportional so it doesn't get distorted? So what that's doing is it's making both sides grow or shrink by the same factor. Factor means multiplier. Okay, so getting half as big, right, on both the height and the weight or the width are keeping it proportional. Right? If I double the length and the height, right, then he's going to get big, but he's growing in proportion. So that corner piece, when you pull that and it maintains the proportionality and not distorting, is multiplying the height and the width by the same amount. So we'll keep that in mind, right? That keeps a ratio the same. So I'm going to go back down to where I was, that we've explored the idea, right? And I'm pretty confident this time. Yeah, I finally got them to stay in proportion when I did half at each, right? So here are the numbers, half of 212 and half of 585. So that's the dimensions of this fish's rectangle. Now, when I put those in, right, let's just keep track. So the original height, the original width were in inches, and 212 and 585. Now we're at 1.06 and 2.93 inches. So I'm going to steal my ratios up here that I can just adjust so that I don't have to type so much. So let's look from, as I compare height to width, 2.12 to 5.85, that's no different, right? That's my original fish. Now, I need 1.02, or 1.06 to 2.93. So notice the bottom is about twice as big as the top in both cases, or maybe close to 3 times, because this is almost 3 times. That's almost 6, so it's almost 3 times the bottom. So that's a good sign, right, that maybe we have maintained the ratio. So my hope is that these come out actually equal this time, and we can say they're in proportion. So how can we tell? So one way would be to divide and get a decimal for both and get the unit rate. The unit ratio would be per 1 for both, so that would help me compare. So I'm going to do that. 212 divided by 585 is 0.36. That also means that the height is 36% of the width. Right? So we've done interpretations relative to percents. And this one, let me see, 1.06 divided by 2.93 is 0.36. Ooh, it's a little different. See that? But 0.36 is the same. And then after that, it's a little, actually, if I round it to 3 decimal places, they would match. So I'm going to call that good because I'm thinking that's close enough, and that my measurements might not be perfect out to, more decimal places. So I think that's pretty good, right? They both came out about 0.36 to 1, and I think just the difference is just in measurement, rounding and whatnot. That slight discrepancy. So both have a height that's 36% of their width. So this time I have a proportion. Another way to check a proportion is to check the cross products. If two ratios are equal, the cross products are equal. So let's check. Let me see. So that would mean 2.12 times 2.93. So I'm multiplying the diagonal values. Okay, I'm not trying to multiply these fractions together. I'm just doing a check. So I got 6.92 for that side. And if I do 5.85 times 1.06, 6.201, so really close. Oh, I wrote the wrong one on that first one. It's 6.21. Sorry about that. So they both come out roughly 6.2, so it sounds like they're really close. Maybe if one of them got rounded, that digit, and the other one didn't, it might have that discrepancy, right? So that checks out. Now, the other ratio, remember I wrote a different ratio before for this problem, but I did the original compared to the adjusted. Let's try that with this fish. So 2.12 to 1. This was comparing, remember, height to height. So I would need an 0.6 there. So the height of the original compared to the height of the adjusted, compared to and then we're going to compare that to the width of the original in comparison to the width of the adjusted. And so what you should find by checking these ratios, either of those two ways would work, right, is that they're indeed equal. Okay. So even if you look at the cross products, notice you're multiplying the same exact two numbers together that you were before. They're just, some of them have just switched places a little bit. So there's actually a lot of ways to set up a proportion, as long as you're aware of how your ratios are, what order they're in. You just need to stay consistent with that on both sides. So that's important to remember. I could even switch these around. Like I could do width to height, right? Or I could do adjusted to original. It doesn't really matter which one went on top or bottom, as long as I do the both of the sides of the equals the same. Okay. So again, I have the conclusion on this one that shows that they actually are proportional. Okay. Now, number 2. So now, suppose another image was to be enlarged. So we don't have that image. Maybe it's like a billboard, or maybe you made a little sign for a company and they want to make it big. Its original dimensions are here, 5 by 8. And the goal is to make it so that it's 8.45 by something. So sometimes this happens when you're doing artwork or graphic design, where the part of it might be set based on maybe a technology that you have to use, or the size of frame that something is supposed to fit in, like an actual physical frame. So there's the scenario, right? So we're enlarging it. It's not a very big picture, 5 centimeters by 8, and we need to make it bigger, 8.45 by something. So how could I do that? There's actually a few ways, and my guess is that some of you are already coming up with a way. So we're going to look at a few, but I'll start with, let's just set up some ratios. So one thing I could do would be, I'll just set up the original. Maybe I'll use this right here because I can steal it. How about we just use the original to the adjusted ratios. So if I want to keep I want to go 5 centimeters, and I want to make it 8 centimeters. And the width I had as 8 centimeters, but now I want it to be, I don't know, I'll call it X, because we're more advanced than question mark, right? So I need to find the new height, or I'm sorry, the new width. So there's a few ways we could try to do this. We could try to see, like, how many times bigger is 8, not how many more. Like, I can't just say 5 plus 3, because remember, adding the same amount to both parts of a ratio doesn't maintain proportionality. But if I multiply, it does. So one way we could solve by figuring out the constant factor. And by that, I mean, what could I multiply 5 by to get 8? Because I could just do that to the 8.45. So remember when the fish was half as big? So that half was actually the constant multiplier. Maybe you can see that here, I don't know. Yeah, up here, right? So 2.12 compared to 1.06, I took half of that, and I get 106. So the top was multiplied by half, the bottom was multiplied by half, or you could say divided by 2. So anyway, I could do that here. I could say, well, let me see, 8 divided by 5, 8 divided by 5 is 1.6. So I could say, oh, so the width must be 1.6 times the height. So that means I'll just take 8.45 times 1.6. So we did this kind of idea back in Module 2, 13.52. Would be the height that I need, and it needs to still be in centimeters. So the new width would be 13.52. So, and how did I get that? Remember, I did 8.45 times 1.6. Okay? Now, what else could I do? So I had this equation. It is an equation, and you've practiced solving equations. So you could solve, oh, big font all of a sudden. We could solve the equation for x. Just treat it as an algebra equation. But to solve for x, the easiest way to solve a proportion is by using the cross product concept. So I'm going to take the cross product 5x, and you probably remember doing this now if you hadn't already in prior math classes. And if I take the diagonal product that way, I get 67.6. And now I can divide both sides by 5 to find out my final x. 13.52. So notice it agrees with our other answer, or the answer we did the other way, right? So we kind of did method 1, figure out the constant factor and then use it. Or method 2, solve the equation, right? Do the algebra. So that'll be really handy because the proportions that we have, I think that the cross product way becomes very efficient. But it's good to understand both ways because you get to understand the connections between things. Now, just as a final thought, we're about out of time on this video. When I have a fish, I can actually hit the log aspect ratio. So this is just like a trick for in case you are doing some work with things. So that's on, right? And so if I want to change